Hello everyone, welcome back to Science Free. In this tutorial, we'll be doing lesson 2 on sets, and the subheadings are subsets and set notations. The set A is said to be a subset of set B if every element in set A is also an element of set B. Now here is an example. So we have two sets, which are set A and set B, because every element in set A are also in the set B. We can then say that set A, which is the first set, is a subset of set B. And this sign is the subset sign. Whenever we have two sets, set A and set B, and set A doesn't contain any element that is in set B, then we say that set A is not a subset of set B. And we write the sign between set A and set B, which means not a subset. Whenever set A contains the same amount of elements that are in set B, then we say that set A is a proper subset of set B. And we use this sign to represent that. We have a set containing A and a second set containing B, D, C, and A. What sign do you think should be placed into this box to make the statement correct? As you can see, the first set contains an element A. And also A can be found in the second set. So we can say that the first set is a subset of the other by placing the sign. And what about this one? Is the first set a subset of the second one? Well, no, because the first set doesn't contain any elements that are in the second set. Given that A equal a set containing X, such that X is a prime number, and set B containing a set X, such that X is an odd number. Is set A subset of set B? Well, we can change both set A and set B from the set builder method into the listing method. Since set A contains prime natural numbers as its element, we can write out the first three prime numbers. And for set B, which contains only odd natural numbers, we can write at least 4 of those odd numbers. So in set A, the first 3 elements can also be found in set B. Which makes set A a subset of set B. Let's now focus on finding the number of subsets of the set. Now think of this. Jordan brought a lunch kit to school which contains a chicken sandwich, an apple, and a soda. The set X above is showing all of what Jordan brought to school, which is also the elements of the set. Jordan could decide that he will have the chicken sandwich only. We have to write a set to show that he could have the chicken sandwich only. He could choose just the apple. Or he could choose that he only wants to have the soda. He could choose to have both the chicken sandwich and the apple. He could choose the apple and the soda. And he could choose the chicken sandwich and the soda. He could also choose to have everything. What if he's not so hungry? He could choose to have nothing and bring his lunch home. We represent that using empty pairs of brackets. Now let's count the number of subsets we got from the set X, which contains Jordan's lunch. After counting, we can see that we got 8 subsets from the set X. In order to arrive at the answer much quicker without writing out the subsets, we could use a formula, and that's 2 raised to the power of n. N is the number of elements of the set. And as you can see, there are 3 elements of the set X. So we can write 2 raised to the power of 3. And that will give us 8 subsets. This is the last example. We want to find the number of subsets in the set which is denoted by A, using the formula. If we count the elements, we will see that there are 4 elements of the set. And the formula is 2 raised to the power of n, which is the number of the elements. So we raise 2 to the power of 4. And that's equal to 16. Thank you for watching. If you have any questions, please leave them in the comments section, or you could send us an email through our email provided in the description.